Welcome to Creative World. In this video, we will solve Chapter 3 Learning Assessment E3.20. While solving this problem, we will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Learning assessment E3.20. Use loop analysis to solve the network in example 3.5 and compare the time and effort involved in the two solution techniques. You may see the solution of example 3.5 in the book. Now we have to solve that same example using loop analysis technique. This is the circuit diagram of given problem. Inside this network, first of all, we have to assume the directions of currents in closed loops. So I am assuming 3 currents are flowing inside 3 loops in clockwise directions each. Labels of these currents are I1, I2 and I3. According to the directions of these currents, polarity notation across resistive elements are marked. One more thing which I forget to tell you is that we have to calculate the value of this voltage V2, because in example 3.5 it is asked to calculate the value of voltage V2 on this node. Now we will start applying Kirchoff's voltage law inside this closed loop to calculate the value of current I1. For that purpose, we will start from here. Current entering terminal is positive, so voltage across this 6 kilo ohm resistance will be taken with positive sign. Now voltage across this resistance is the product of current through it and the value of resistance itself. This resistance is common between two loops, so two currents will be flowing from this resistance and both are opposite in direction to each other. I2 will be flowing in upward direction while I1 is flowing in downward direction. Now because we are inside this loop and we are taking voltage according to the direction of current I1, so we will assume that I1 is larger than I2 and resultant current which is flowing through this 6 kilo ohm resistance will be equal to the difference of these two currents, I1 minus I2. So voltage equation for this 6 kilo ohm resistance will be I1 minus I2 multiplied by 6 kilo ohm. Next, voltage across this voltage source will be taken with negative sign because current is entering from negative terminal, minus 12 volt. Next, voltage across this 12 kilo ohm resistance will also be taken with positive sign because current is entering from positive terminal, and again through this resistance two currents are passing, both are in opposite direction to each other, so their difference will be equal to the resultant current that will be passing through this 12 kilo ohm resistance. Now the voltage polarity is taken according to I1, so I1 minus I3 will be equal to the resultant current through this 12 kilo ohm resistance, and voltage across this resistance will be equal to I1 minus I3 multiplied by 12 kilo ohm. Now open these brackets, multiply 6 kilo ohm with variables inside the brackets. The equation will become 6k I1 minus 6k I2. This minus 12 is placed on the other hand side of equal in order to separate it from variables. Here 12k will multiply with I1, it will become 12k I1 minus 12k I3. Now add same variables together, 12k I1 and 6k I1 will become 18k I1 minus 6k I2 minus 12k I3 equal to 12. Now we cannot further solve this equation, so we will leave it for now and label this equation as equation A. This is the first loop equation of this network. Move towards second loop. Inside this loop, we will start from here. Current entering terminal is negative, so 6 volt will be taken with negative sign. Next, current entering terminal is positive, so voltage across this 6 kilo ohm resistance will be taken with positive sign. Now at this time we are taking the polarity of voltage across this 6 kilo ohm resistance according to the direction of current I2. So again this current I2 will be considered as higher current than I1, and resultant flowing current through this 6 kilo ohm resistance will be equal to the difference of these two currents. But for now we will consider I2 as higher current than I1. So voltage across 6 kilo ohm resistance will be equal to I2 minus I1 multiplied by 6 kilo ohm. Next, current entering terminal is positive, so voltage across this 12 kilo ohm resistance will be taken with positive sign, and voltage across this resistance is the product of the difference of these two currents because these two currents are passing through it in opposite direction. Again we are considering voltage according to the polarity of I2, so I2 minus I3 will be equal to the resultant current of this 12 kilo ohm resistance, and voltage across it will be equal to I2 minus I3 multiplied by 12 kilo ohm. All of these are equal to 0. Now open these brackets, multiply 6 kilo ohm with variables inside the brackets. This minus 6 is placed on the other hand side of equal, and this 6k is multiplied with I2, it will become 6k I2. Similarly, minus 6k I1. Here 12k is multiplied with variables inside the brackets, 12k I2 minus 12k I3. Now rearrange the equation and add variables having same values together. Minus 6k I1 plus 18k I2 minus 12k I3 equal to 6. We cannot further solve this equation, so we will leave it for now and label it as equation B. Now apply Kirchoff's voltage law inside this third loop. Start from here, current entering terminal is positive, so voltage across this 9 kilo ohm resistance will be taken with positive sign, and voltage equation of this resistance is the product of current I3 and 9 kilo ohm. Next, current entering terminal is positive, so voltage across this 12 kilo ohm resistance will be taken with positive sign, but for now we are taking voltage across this resistance according to the polarity of current I3. So current I3 minus I2 multiplied by 12 kilo ohm will be equal to voltage across this 12 kilo ohm resistance. I3 minus I2 multiplied by 12 kilo ohm. Similarly, here I3 minus I1 multiplied by 12 kilo ohm will be equal to voltage across this resistance. Now open these brackets. The equation will become 9k I3, 12k I3 minus 12k I2 plus 12k I3 minus 12k I1. Arrange the equation and add values having same variables together. The equation will become minus 12k I1 minus 12k I2 plus 33k I3 equal to 0, and it is the third equation of this network. Now we will try to solve these three equations which we retrieved using loop analysis of the network. We are interested to calculate the value of current through this 6 kilo ohm resistance. If we able to calculate the value of this resistance current, we will be able to calculate voltage across this resistance that is labeled as V2, and it is the required parameter to calculate. Now in order to calculate the value of current through this resistance, we should have the values of two currents, I1 and I2, because these two currents are passing through this resistance. So we will try to solve these three equations for current values I1 and I2. First of all, we will take equation A as it is and multiply equation B with 3. The equation will become minus 18k1 plus 54k2 minus 36k3 equal to 18. Now add these two equations together. Minus 18ki1 and plus 18ki1 will cancel out with each other. Plus 54ki2 minus 6ki2 will become 48ki2. Similarly, Sum of 36k I3 and 12k I3 will become 48k I3, and on the other hand side of equal, 18 plus 12 will become 30. Now take equation C as it is and multiply equation B with minus 2. The equation B will become plus 12k I1 minus 36k I2 plus 24k I3 equal to minus 12. Now add these equations together. Minus 12k I1 and plus 12k I1 will cancel out with each other. Minus 36k I2 and minus 12k I2 will become minus 48k I2. 33k I3 and 24k I3 will become 57k I3, and on the other hand side of equal, minus 12 will left. Now if we focus on these two equations, if we add these equations together, this 48k I2 and minus 48k I2 will cancel out with each other, and only one variable I3 will left. So we will be able to calculate the value of I3. Add these equations together. These two will cancel out with each other. Plus 57k I3 minus 48k I3 will become 9k I3, and 30 minus 12 will become 18. Now in order to calculate the value of variable I3, divide on both sides with 9k. Current I3 will become 2 milliampere. After calculating the value of current I3, we are able to calculate the value of current I2 by replacing this I3 with its value. I3 is replaced with 2 milliampere. Now take the product of minus 48k and 2 milliampere. It will become minus 96. Place minus 96 on the other hand side of equal. The equation will become 48k I2 equal to 30 plus 96. Now add these together and divide with 48k, because we are interested to calculate the value of I2, that will become 2.625 milliampere. Up to this point, we have succeeded to calculate the value of current I2 and I3, but still we are not able to calculate the value of voltage V2, because in order to calculate the value of voltage V2, we should have the value of current I1 as well. So in order to calculate the value of current I1, we will replace current I3 and I2 in equation A. So replace the values of current I2 and I3 in equation A. I3 is replaced with 2 milliampere and I2 is replaced with 2.625 milliampere. Solve this equation. The equation will become 18k I1 minus 15.75 minus 24 equal to 12. Now place these two constants on the other hand side of equal and add these values together. The equation will become 18k I1 equal to 51.75. In order to calculate the value of current I1, divide on both sides with 18k. So the value of current I1 will become 2.875 milliampere. Now in order to calculate voltage across this 6 kilo ohm resistance, we have to find the resultant current through this resistance, that will be equal to the difference of these two currents, I1 minus I2. Here current I1 is larger than I2, that's why I2 is subtracted from I1. So the resultant current will be equal to 0.25 milliampere. After getting the value of current, we are able to calculate voltage across this 6 kilo ohm resistance using Ohm's law. V2 will be equal to the current of this resistance multiplied by its value. So replace I 6 kilo ohm with its value, that is 0.25 milliampere, and the product of 0.25 milliampere and 6 kilo ohm will result 1.5 volt. So the value of voltage V2 is 1.5 volt. Now we will conclude our solutions. In example 3.5, this problem is solved using nodal analysis technique, but in this learning assessment 3.20, we have solved this same example using loop analysis. Although both techniques are valid and both are justifying the same answers. But in case of nodal analysis technique, this problem was very easy to solve and it required less time and effort to solve it. But in case of loop analysis technique, it required too much time and effort to solve it. So we can say that all of these circuit analysis techniques are good for the solution of complex problems, but right selection of solution technique might save our time as well as effort to solve problems. So this was all about chapter 3 learning assessment E3.20. Thank you. See you again in next video.